हेलो फ्रेंड्स, वेलकम टू माय चैनल। मैं हूं आपका दोस्त महेश कुमार। आइए स्टार्ट करते हैं क्वेश्चन रिलेटेड टू हाइड्रोस्टैटिक फोर्सेस ऑन सरफेसेस। इन दिस वी आर गोइंग टू टॉक अबाउट द मूविंग टैंक। So question related to moving tank. Here the question is, a rectangular tank is moving horizontally in the direction of its length with a constant acceleration of 2.4 meter per second square. The length, width and depth of the tank are 6 meter, 2.5 meter and 2 meter respectively. If the depth of water in the tank is 1 meter and tank is open at the top, then calculate the angle of the water surface to the horizontal, the maximum and minimum pressure intensities at the bottom, and the third point is the total force due to water acting on each end of the tank. So friends, it is saying that this is the tank. It is moving with acceleration 2.4 meter per second square. Here this total length is equal to 6 meter and this depth is equal to 2 meter. Friends, don't be confused. I am making this little bit wrong dimensions. So please understand, this length is 6 meter and this is 2 meter. So this length should be more. So please understand this one. This is 2 meter only. This length is 2 meter and this length is 6 meter. So little bit please understand. Now this is the initial, this is the initial level, water level, but when this tank is moving with acceleration 2.4, so particle of the liquid will shift and it will form a new surface level AB. Okay friends, new surface level AB. So this is the new free surface when tank moves with acceleration 2.4 meter per second square. This is the initial, or you can say old one. Now here dimensions has given acceleration 2.4 meter per second square, length equal to, this length is equal to 6 meter, width is equal to 2.5 meter and depth of the tank equal to 2 meter. That's why I'm saying that friends, I'm making little bit wrong dimensions. So please understand, this length is equal to 6 meter and this is 2 meter. Please correct it. Now in this it is saying that the liquid level is 1 meter depth. It means initially whatever liquid depth is there, this height is equal to from the bottom, this height equal to, you can say here this point is F. So dF and here G, dF or EG value is equal to 1 meter. Now we have to determine the angle which is making with the horizontal. So friends, what is the angle? So first point is this angle we have to determine. The angle of the water surface to the horizontal. Okay friends, so here you see we know that the tan theta equal to minus a by g, Negative sign shows that the slope is straight line and it is downward direction. Negative sign shows that it is a straight line and downward direction. So we will take the magnitude value. So tan theta equal to a by g, and the a value has given 2.4 meter per second square and g value is equal to 9.81. So friends, from here we are able to calculate the slope theta, we can say the angle theta, we are able to find 2.4 divided by 9.81, or the value is the value is 2.4 divided by 9.81, so its value will come 0.2446. Okay friends, so this theta value is equal to tan inverse theta value, so it will come friends 13.747, okay, degree. So first point it has clear. So the angle of the water surface to the horizontal is 13.747 degree. Okay. Now the second point is that the maximum and minimum pressure intensities at the bottom. The maximum and minimum pressure intensities at bottom. Okay friends, now we know that the pressure at the bottom is equal to what? At different places. See friends, here pressure at the bottom, at this end the liquid level is this one, A to F is the liquid surface, liquid level. At a rear end, this end is known as rear end and this end is known as front end. So here the liquid level is up to this and here liquid level is this much. So minimum is what? Minimum at liquid level is this much. If you consider this point, the liquid level is more. So the pressure at this point is greater than this point. So the minimum pressure intensities at the front end, because the liquid level is we can say very less at the other point, and here the liquid level is more, so pressure intensities will be more. So the maximum pressure कहाँ होगा friends? Maximum pressure at rear end and it is equal to rho g h1, and minimum pressure at front end equal to rho g h2. So this end is equal to what? Here this AF length is equal to h1 and here BG is the h2. So friends, I am making here this length is equal to h2 and this length is h1. Okay, now we have to calculate this value because this end up to original is this one and here rear end it is rising and here front is it is falling. So both this value EB and AD equal to same because this length half 3 meter and 3 meter and theta is same. So AD and EB is same. Okay friends, so we have to find this value. So here what we will do, we will add 1 meter plus and here we will minus 1 meter minus this value. So we are able to calculate the H1 and H2, and if this H1 and H2 calculated, so from here we can find the maximum pressure and minimum pressure. Getting friends? So for calculating this one, we know that friends, here you see tan theta is equal to minus A by G, or we can say tan theta is equal to A by G, correct? And we know that value here A by G equal to how much? We know that this value is equal to, this value already calculated here, this A by G value is equal to 0.2446. 0.446. Friends, if you see here in this triangle ADC, triangle ADC, tan theta is equal to what? AD by DC, yes, CD. So tan theta is equal to AD by CD and tan theta is equal to A by G. So both we are equating here. So AD by CD is equal to this value. So from here AD is equal to what? CD is equal to what, friends? CD is equal to 3 meter because total length is equal to 6 meter. So CD is equal to, this is 3 meter, and the theta we know, theta is equal to, already calculated here, theta value calculated here, or we can put, instead of theta we could put tan theta equal to A by G. Directly we will put it here, and from here we are able to calculate this AD 2.4 into 3 upon 9.81, or we can say 0.2446 into 3. So all the things will come here. AD is equal to 0.7339 meter. It means, friends, the here the rear end value will come. H1 value is equal to what? From here the H1 value is equal to 1 plus AD, and H2 value is equal to 1 minus this EB. Okay, friends. So from here this 1 plus 0.7339 is equal to 1.7339 meter H1 value, and 1 minus 0.7339 equal to how much it will be? This is 1 minus 0.7339, 0.2661. Okay, friends. So from here we are able to calculate the pressure. Friends. So what is the pressure here? So friends, what is the pressure here? Pressure is equal to what? So pressure is equal to, we can find the pressure. So maximum pressure P1 equal to rho G H1. Rho is the water density is equal to 1000 into 9.81 into 1.7339 meter. So it will come around 9810 into 9.81 into 1000 is equal to 9810 into 1.7339. So it will come 17009.55, what we can say, Newton per meter square. Okay, friends, the minimum pressure is equal to what? P2 is equal to rho G S2, and the value is equal to 1000 into 9.81 into S2 is equal to, S2 value is equal to what, friends? S2 value is equal to 0.2661 equal to how much it will come? 9810 into 0.2661, 2610.44 Newton per meter square. So friends, this is the minimum pressure, and this value is the maximum pressure. Getting, friends? So back end will give maximum pressure and front end will give minimum pressure. Now friends, now we have to find the total force due to water acting on each end of the tank. So friends, maximum force is equal to what? We know that the force. See here, if pressure is more here, force is also more. Friends, last lecture, actually I was confused how to calculate the force. So we are able to find here this F1 force is equal to, one formula is there, rho GB H1 square by 2 Newton, or we are able to calculate, we know that the force is equal to pressure into area. So friends, if you see here, if this is the tank, and suppose liquid is like this, here some width is there, here some width is there. So if you will see the, from this view, the pressure is working at a rectangular plate. It means here this is the width b equal to, this is the b equal to 2.5 meter, and this is the h1, this length is h1. Getting? Here up to this the liquid is there, so this end is h1 and the width is equal to, this is the b. So if you see here, it is a rectangular plate. So at the rectangular plate, what is the pressure? Total pressure is equal to what? F1 is equal to pressure into area. So what is the pressure? Pressure is equal to rho g into h bar, or we can say force is equal to what? Rho g a into h bar. It is the static force now. It is the static force rho g a h bar. Getting, friends? Rho g a h bar is the static force. It means rho g h bar is the pressure. And from here, this rho g area is equal to what? Area is equal to b into h1. Here first we write b into h1 is the area, and h bar is equal to what? H bar is the distance from this point to this point. So h bar is equal to, we can say h1 bar equal to h1 by 2. So here h1 will take, because we are taking this end. So h1 bar is equal to what? h1 by 2. So from here it will come rho g b h1 square by 2. Getting, friends? So from here we are able to calculate. Either you remember this formula, or from here rho g a h1 bar, and h1 bar is equal to this height. Okay. Now force is equal to F1 is equal to, already calculated. One time I more explain. If the left face here, just this is h1 bar, this is b, this is the center point. So this is h1 bar is equal to what? This is the h1. So h1 bar is equal to h1 by 2. So rho g a h bar is the static pressure. So rho is equal to, for in this case, 1000 into g is equal to 9.81 into area is equal to b into h1. B is equal to 2.5 into h1 is equal to what? 1.7339, and h bar is equal to what? You can say h1 bar here. So h1 bar is equal to what? This 1.7339 divided by 2. Okay, friends. So this is the force at the rear end. This is the force at rear end. Okay, friends. So from here we are able to calculate the force. So this is 9810 into 2.5 into 1.7339 whole square divided by 2. From here we are able to find, friends, it's 9810 into 2.5 into 1.7339 whole square divided by 2. So friends, it will come 36866.09 Newton. And minimum force F2 at end, here at this end, front end, F2 is the force at front end. This is the rear end force. So front end, same friends, rho GB H2 square by 2 Newton. So F2 equal to, we'll put directly here, 1000 into 9.81 into 2.5 into H2 value is equal to what? H2 value is equal to 0.2661 whole square divided by 2. So from here we are able to calculate 9810 into 2.5 into 0.2661 whole square divided by 2. So 868.29 Newton it will come. Getting friends? Here the F2 force is equal to this one, and F1 force is equal to how much? This value has come. Getting friends? So what is the accelerating force? Accelerating force is equal to what? This mass into acceleration. So what is the value of this one? This value is equal to, कितना चाहिए इसको accelerating करने के लिए with this acceleration 2.4, what is the force needed? So it is equal to the F1 minus F2. One more point is there. If you calculate, so accelerating force F acceleration is equal to F1 minus F2. Getting friends? So F1 minus F2 is equal to what? This part is completed. This is the extra part I am telling. We are able to calculate whatever data has given. Angle we have calculated, maximum and minimum pressure has calculated, and the force we are able to calculate it. Now this is the some extra features, extra points I am saying. What is the accelerating force by which the tank is moving? So हमें कितना फोर्स चाहिए? So F accelerating force is equal to F1 minus F2. So this is equivalent to 16866.09 minus 868.29. Okay friends, so it will come around here. You see, this is the F2 value at 68.29. So 36866.09, correct? 36866.09 minus answer equal to, it will come around 35997.79 Newton F acceleration. Getting friends? Friends, can we recheck? Can we recheck that F acceleration is equal to 35997 approx it is coming or not? We know that friends. Let's verify it. Let's we should do some verification. So how much it is coming? Why this F acceleration? We know that friends, this F acceleration value is equal to F acceleration. We know that friends, this is the mass into acceleration, correct? This is the mass into acceleration. So how much it will come? Mass is equal to what? Rho g, rho into v, density into volume into acceleration, correct? So density is equal to 1000 water into volume is equal to what? Volume is equal to volume of the liquid inside the tank. So length is equal to 6 meter, width is equal to 2.5 meter, and the depth of water is equal to 1 meter. So how much is there? Length is equal to 6 meter into width is equal to 2.5 meter into 1 meter depth. This is the mass of, this is the volume of the liquid into density. So it is represented as the mass, and 2.4 is the acceleration. So how much it will come? Let's calculate. So it will come 1000 into 6 into 2.5 into 2.4. So friends, it is giving here 36000 Newton. Correct? Here F acceleration is equal to how much? 3600 Newton. Friends, it is equivalent to, see here, 35997.79 or here 36000. So almost approx both values are same. Correct? This both value, this F acceleration F2 minus F1 minus F2 is equal to 35997 approx 36000 Newton, and here mass into acceleration give the same value. So friends, this is the cross verification that F acceleration is equal to the F1 minus F2. Okay friends. सो फ्रेंड्स, मेरा एक्सप्लेनेशन अच्छा लगे प्लीज लाइक कीजिए, कमेंट कीजिए, मेरे चैनल को सब्सक्राइब कीजिए। कुछ डाउट हो तो फ्रेंड्स आप कमेंट बॉक्स में पूछ सकते हैं, आई विल रिप्लाई दैट पॉइंट्स। ओके फ्रेंड्स, थैंक यू।